So as you can see here, we're defining our access port registers right here in this top portion. Next, we're defining our LEDs. They're shown in this portion right here for port F. We also are defining our switches, switch 1 and switch 2, input from PF4, PF0, and we're also defining our outputs to PF3, PF2, PF1, which is the multicolor LED. Alright, into main, initializes the real board grader, initializes our ports PF4 to PF0, and inside our while loop, we give switch 1 and switch 2, set them equal to them at access registers. And the cool thing about the switches is that they're negative logic, so a 0 is true and a 1 is false. So I went and put not signs in front of the switches. So if not switch 1 and not switch 2, that means both are pressed, the LED will turn blue. If not switch 2 and switch 1, which is pressing switch 2, the LED will turn green. Next, if not switch 1 and switch 2, so pressing switch 1, the LED will turn red. And of course, else, if neither switch is pressed, the LED will be off. So let me run the simulation here. We'll go into options for Lab 2. And we'll make sure that the simulator, which is checked off right here, we want to make sure the simulator is checked off. I'm going to hit OK. I am going to build the target. I'm going to debug. Alright, and so I'm going to run my code by hitting F5. That just brought me into my while loop. I set a breakpoint at 64 right before the while loop. So how you put a breakpoint on is just double clicking, or just single clicking, sorry. I can single click and bring a breakpoint up. And I take that back. I previously had one on 69. And so let me run it past the while loop here. Let me debug, start. Oh, I apologize, that just took it out. Let me go back into debug here. Let me run the program. And then let me bring my simulator up. As you can see here, when switch 1 is pressed, the LED is red. When neither switch is pressed, the LED is not on. When switch 2 is pressed, the LED is green. And when both are pressed, the LED is blue.